This is the fourth video in a series on how to do a cybersecurity risk assessment and forms part of the first stage of the GRC lifecycle, assess risk. In the previous video, we learned what cyber risk is and how to look for it. So in this video, we will apply what we've learned to our fictional client scenario, cargo trail logistics. So taking what we covered so far, what is a risk? It's a threat acting on a vulnerability leading to consequences. Such as in this situation, we have the threat of a slippery banana peel on the floor. The vulnerability is that the person walking is not paying attention, and potential consequences include personal injury, embarrassment, and learning a tough lesson. A risk also has a likelihood of it occurring and an impact if it does occur, leading to an overall risk rating, which is how bad or dangerous the risk is. In this situation, we have an elderly person walking at night, distracted by their phone, and they don't have their glasses on. So the likelihood of them slipping on the banana peel is very high. And because they could fall into not one cactus, but two, and then fall onto the ground, the potential impact to them is very high. And so the overall risk rating is extreme. We also looked at physical security, cybersecurity, and information security and the differences between them. We looked at the information security CIA triad, covering confidentiality, integrity, and availability. We've also looked at data flow mapping, where we visually represent the different components in an app or a system, including users such as customers. And we look at the type of information flowing between the different components and different users. Now we need to take all of this and apply this to our scenario. If we go to our risk assessment document, the section we're going to focus on is the risk findings. Now, each risk is represented by its own table. At the moment, even though we've learned about threat sources and risk factors are basically like vulnerabilities, it's factors that contribute to the risk, likelihood, and severity. We've got things like controls and consequences. At the moment, we're just going to try to come up with the basic idea behind each risk. And in a later phase in the risk assessment process, we will then complete each risk by looking at the specific sources, specific consequences. We'll then have a separate look at things like ratings. So for now, we're just going to be looking at a risk title, which gives us an idea of what the risk is about. We're going to then assign risk IDs, which is basically just a number. So effectively like risk 1, risk 2, risk 3. And then we'll look at the risk description. So we take the idea behind the title and then we expand it out into more detail, listing out some of the impacts. This is more of a short narrative form of the risk. So if we look at the business process diagram that we have for cargo trail logistics, this is a visual representation of different user groups using different tools and systems, things like this. And one of the things that we notice if we were to apply what we learned in the previous video around the CIA triad, if we look at confidentiality, we can see that different types of users access different types of systems. And the simple fact is, if you're dealing with any kind of confidential information, because confidentiality is precisely about controlling who accesses the information, it's not meant for everybody to see, you can almost always find a risk around access control. Basically, that you don't have sufficient access control, or there might be mistakes with access control such that we have people who are simply able to access things that they're not supposed to access. If you have confidential information, it's possible that you have an issue with access control. So it's very unlikely that you don't have confidential information. There would be some situations like one time I did an assessment on a website for a government agency, and it was just a simple website that showed information meant for public consumption. So there wasn't actually anything involved that wasn't meant for everybody to see. You couldn't log into the website to actually do anything. The website didn't store anything confidential. It was literally just a website informing the public of things that they could access through this government agency. And it was pretty simple, actually. So in the absence of confidential information, there may not be an issue around access control as much, but in a lot of different businesses, you're almost certainly going to have confidential information. So this is a risk you should always be looking for, is access control. Now, there's not only the idea that people have access to things that they should not have access to, but what about when people have access to information and they do something inappropriate with it? You may have people who use the fact that they can access something to gain an advantage on someone else. They could abuse their access to the information. You may have what they call malicious insiders, who are people who are within an organization. They have legitimate access to things, but they're not going to use their access appropriately. They might use it for their own gain. They might steal information and then try to blackmail the company. They might try to blackmail individuals. They might be part of a cybercrime network. Actually, they might have infiltrated the company and they're trying to use their access as part of a larger scheme. So we can identify people having access to things they should never have access to in the first place, and then people who misuse access that they legitimately have as two risks around access control. So we can remove the directions here, and then we can say that our first risk is unauthorized access to cargo trails, logistics files, and systems. If we take the concept of access control and expand that, we can think it's not just about accessing information that you're not meant to see and that you're breaching the confidentiality of the information. But if you're not meant to access something, it could lead to that information having its integrity damaged by it being modified when it's not supposed to be modified. It could be deleted. You may also have access to system files such that you can corrupt them, you can damage them, and cause a system to have a problem. So, a device, for example, because when we talk about access control, we are talking about, of course, people who can hack in as well. So, people who may want to disrupt your ability to access information. So, they may get access to your device or a server, and then they deliberately do something such that the system cannot be used. You cannot access information. So this can be an accessibility issue through service disruption. But we can also have not only information disclosure, breaching the confidentiality, but we can have information modification or loss. And we're going to keep this as a more general statement that files and/or systems are compromised due to access by an unauthorized user. And for our next risk, we will put in the misuse of access. This assumes that someone is meant to have access and they are simply using their access inappropriately. This can also mean that you have files who are disclosed because someone may have access to files, but then they can take those files and misuse their access by disclosing them to other people. They could accidentally or deliberately share them with other people. Obviously, if someone has access to something, they're meant to do certain tasks. They may do something they're not supposed to do, where they delete information they were not supposed to delete accidentally or deliberately. And in a similar way, they can also use their access to disrupt the service by damaging a server or a device. Since we've gone from just talking about confidentiality to also talking about integrity and availability that we derive from the idea of access control, we can also look at the idea of malware. In this case, we're specifically going to look at ransomware because this is a very common type of malware used by cyber criminals where it encrypts files that you want to access on your device, or it might encrypt the files that allow the device to operate so that it simply cannot operate. Could be a device or a server. So we're branching out into covering integrity and availability as well. We need to note, though, that even though ransomware is mainly about attacking the integrity of information so that you cannot use it, you cannot access the information because the information itself has been, say, encrypted, it's also about locking your ability to access a device. We also need to consider the confidentiality aspect when it comes to ransomware, because even though it's mainly about attacking information itself or locking you out from using devices, cyber criminals will also try to extract confidential and sensitive information to have an additional card up their sleeve in case you have backups of your other information and you don't want to pay their ransom. So we have to consider confidentiality here as well. From ransomware, we can then move on to a broader look at things like employee devices being compromised, because there's always a risk that an employee clicks on a phishing email, something like that, or downloads some kind of suspicious file, and then has another type of malware installed on their device. This can also affect confidentiality, integrity, and availability because we're not being specific about the type of malware or what the intentions of the cyber criminal are. So we have to consider all of these options. If we have another look at our business process diagram, we can see up the top for our digital logistics platform, we have customers ordering and monitoring shipments. We have our logistics operators, freight carriers doing their logistical operations, our ops team doing operations management all through the logistics platform. If we then go down to internal tools, we have all different types of teams using the Microsoft Suite for productivity and collaboration. We store source code in GitHub. We use SharePoint document storage specifically for customer contract management. Basically, we've got a lot of important information moving around, being stored and accessed by people. And if we look at the technical diagram, systems are accessing this information too. And this information is critical for the business to function. And so if we had an issue with this information, if it was accidentally or deliberately deleted or it was modified, and we don't have a backup copy, this could give us serious issues in the running of the business. So another quite common risk is the idea of not backing up critical information. We can then add in as our fifth risk, loss of critical business data. And it's possible that you lose critical business data, but ideally you'd have a backup copy of it to resolve this issue. So it's really around not having backups. Another very common risk that we can look at is not having adequate incident response processes. This is the idea that when you have some kind of security incident, which is not necessarily someone hacking in, it could be someone doing something internally, a malicious insider. It could be someone doing something accidental. An employee could accidentally share confidential information outside of the company, something like this. We may not have systems in place to detect that something has happened, to then know what to do about it, because you don't want to go and do nothing because you are panicking and you don't know what to do. You also don't want to do the wrong thing. You don't want to think you're helping by turning the system off, for example, when you might be helping to delete the evidence of what happened. So it's important that we consider overarching this entire assessment. When things do happen, you need to have some kind of process in place to respond and recover to security incidents. And it's quite common that companies do not quite have enough. They might have something, they might have nothing, but if they have something, it's often going to be something that they haven't tested. Like employees will not necessarily know what their role is. They won't know who they're supposed to call, what qualifies as an incident and should be reported. And then the people they report to may not know who to escalate to, what is the procedure. You might have multiple different ways of doing it, leading to confusion and panic. So this is a very important thing to have in place, and it's quite a common risk that companies will not quite have a suitable incident recovery, response and recovery process in place. If we now start thinking about systems, we go back to our data flow or technical diagram. The centerpiece for cargo trail logistics is the digital logistics platform at the center of the data flow. Now, this is hosted in AWS cloud infrastructure in an AWS tenancy. So we need to consider, to protect the digital logistics platform, we also need to protect the AWS tenancy from being compromised. When it comes to cloud infrastructure, there is normally an arrangement in place where the cloud infrastructure provider, they provide security for the cloud, but you as the user have to provide security in the cloud. This arrangement is called the shared responsibility model, where someone like AWS is responsible for protecting the data center itself. But once you have essentially rented space within the data center for your cloud environment, you have to configure that to be secure. You have to make sure that passwords to access your environment are strong enough, that you have multi-factor authentication, that you haven't accidentally set things to be publicly accessible when they shouldn't be. Having spoken about the infrastructure that runs the Digital Logistics Platform, we can then talk about the DLP itself. Since cargo trailer logistics has this proprietary piece of software, we need to make sure that it is developed properly, that we don't have any coding vulnerabilities in it, which means, for example, instead of someone typing in their username to log in, they can type in essentially computer code. And so the system runs the code and does things that it's not supposed to do if we don't put in place measures to reject that kind of input when you should be typing in something like a username. We may also have made the DLP such that someone can hack in as a regular user. Maybe they compromise the account of one of the employees who has some access to the system. But if we haven't designed the application correctly, they might be able to get a lot more access, where instead of just being able to read files, now they can create files and delete files as well. If we have not designed the application correctly and tested it to make sure that these sort of things cannot happen, or if they can, we need to make sure we fix it. If we also think about the fact that the DLP is hosted on the cloud, occasionally, even though things are generally pretty good in terms of accessibility on the cloud, you do have service disruptions where a data center may have some kind of problem, some kind of connectivity issue, and your app hosted on the cloud may not work properly. This sort of thing does not happen all the time, but you have situations where maybe there's a faulty software update. This has happened in recent years where you can have a lot of disruption because someone made a mistake and the data center software crashes. And then if you are hosted in that data center, your applications can't be used. If we go back and look at the data flow diagram again, we can see the DLP in the center is talking to a lot of other programs. And we do this using APIs, or application programming interface. APIs allow one type of computer program to talk to another one because the API set rules out for how you format and structure data when you're sending it back and forth between different programs. So because we have a lot of different programs talking to the DLP for it to function properly, making sure that we have API connectivity is important. And if we had some kind of problem around this, let's just say a malicious actor was pretending to be customs clearance software. So they send lots of document requests to the customs clearance API. Then our DLP is trying to answer all these requests via API. If we don't have systems in place to recognize this isn't normal to get so many requests, the same type of requests, very quickly, one after another, we can then block wherever that's coming from or do something about it. If we don't have any kind of protection like this, then the whole DLP can be focused on trying to answer all these custom clearance requests, and it doesn't work. We might also have errors when we are originally creating the DLP or when we provide an update. If we modify our API code, then we may not be able to integrate with some of these systems anymore. So we need to make sure that we have this functionality working correctly. So therefore, we can put in a risk for API connectivity and how it's not working correctly. In the information gathering video, we talked about how there is a legacy version of warehouse management software, which means it's software that is no longer being updated to fix bugs and errors and other issues. And so if there is a problem with this software, it's highly unlikely that anyone's ever going to fix it. And so if someone finds out that you're using a certain type of software, they already know exactly how to hack in. So we need to add in a specific risk for the warehouse software being compromised. If we then go back to our data flow diagram again, we see all these different systems that integrate with the DLP. We then need to consider what would happen if one or more of these systems had their own problems, because we've talked about the DLP having availability problems if there was some kind of disruption. But what if, say, the routing engine in the AWS tenancy, what if this had problems? And we also need to consider what types of problems could they be, because we could have the routing engine not working properly, which means we cannot use it to help guide the vehicles on the most efficient route. But a separate issue is that the routing engine, instead of not feeding us information if it was simply not available. We could have the routing engine compromised by a malicious actor, for example, and so it's feeding us incorrect information. They're two different situations. So we need to have two separate risks for these two different situations for this important supplier for the DLP. So we can start off with a risk around the shipment routing engine being unavailable, such that we cannot route shipments optimally. Doesn't mean we cannot route them, but we cannot use this system to give us the most efficient route. We may have some kind of alternative plan in mind, like we may require drivers to have a phone with Google Maps so they can simply use that. We rely on that as the backup plan. And then we've got as a separate risk the idea that the routing engine is actually compromised. And in this situation, we're actually receiving incorrect routing information. So it'll send shipments on an extremely inefficient route. If we go back to this diagram again and we think of other major suppliers where there could be problems with their systems, we can look at, for example, freight carriers, which are obviously absolutely essential for cargo trail logistics to do business because they don't actually ship anything themselves. They simply coordinate logistics companies, subcontractors to do it for them. So we need to have a risk around if we wanted to use a particular freight carrier supplier, but their system was not available. It may be that there is already a process in place to deal with this, but at this point, we're just trying to identify the risks. We're not necessarily making a judgment on whether the risk is high or low, or there are controls in place to mitigate the risk and make it a lot more reasonable and acceptable. We're just trying to identify things that we can find looking at the company's business operations and the context around the company. We can consider this risk of the freight carrier system being compromised as being different to it being unavailable, because if it's unavailable, that means that you're trying to, say, contact a system to tell it you're giving them an order, and they're not necessarily responding and acknowledging that the order's been accepted and they're going to come and collect it. On the other hand, if the system's been compromised, we may be telling the freight supplier, hey, here is an order for you. And they say, okay, that's great. We're going to come and pick it up. And they never do, because whoever controls their systems is giving you these false acknowledgments on an order. And then we have a shipment. Instead of wondering who's going to pick it up because we've given it to this supplier and they're not responding, we're telling the supplier, yes, you can come and pick it up, and nothing's happening. So this is a different situation from the system being unavailable. We then look back at our data flow diagram. Another system we've got is the vehicle telematics system to do vehicle tracking. So we can do a risk around that. This risk, again, has different consequences to the other ones because we are specifically talking about the inability to track shipments. So if we cannot track shipments, then it's difficult for us to tell customers when their shipments are going to arrive. It's difficult for us to determine precisely when a shipment will arrive at a warehouse. So maybe we cannot staff the warehouse correctly because we're not exactly sure, putting people on a shift or not. There are other systems here, but without wanting to be exhaustive and look at every single option, I've looked at a few different suppliers to give you an idea of how you consider different types of suppliers that in this case provide different types of information to let the DLP and the logistics operations of CTL run. You can look at how there are slightly different consequences in different cases. And so you can split these risks out as opposed to just having one risk that, a supplier system is down, in which case there are all kinds of different consequences that will have different levels of severity and impact, different likelihoods. I'm just using this to demonstrate how you can go through and pull out different types of risks, but I don't want to make a really long list of quite similar risks. So instead, we're going to look at something else. If we consider something that is not so tech related, it's the idea that the company receives an invalid invoice that is then paid. In this case, because CTL is a logistics company and they rely heavily on freight carriers, we may receive freight carrier invoices for shipments that never happened. And if you don't have a robust system in place to review things like invoices prior to making payment. It may be from or appearing to be from a supplier that CTL uses a lot. It's just that the shipment never happened. And if you don't have a system in place to verify that the basis for the invoice is correct, that that work was carried out and the amount is correct, you may have people who end up paying invoices that are not valid. There are examples of this in real life where companies pay fake invoices because they don't have a proper system to verify things before they make payment. In a similar way, we may have a company who offers to be a supplier and they're fake. It's not a freight company who intends to actually ship the shipment to where you want it to go. You could have this supposed company show up to collect a shipment and they simply take it and disappear and no one ever sees the shipment again. This is not necessarily related to cybersecurity, but these are things that can definitely happen. And it's worth considering that these just normal business processes that are in place in one way or another across countless businesses everywhere. If you don't have robust processes in place, you can have issues like this that can cause the company problems. If you look back at the third-party dependency information, we've already got some risks around freight carriers, the routing engine, and the telematics provider for shipment location. We also had the IT managed service provider. So we definitely need a risk around these guys because they are the only IT supplier here. And as an IT supplier, they have access to some of our systems. So they can do bad things if someone over there were to have their account compromised or someone over there is just a bad person. So we're going to have risk around the account of someone working at the IT managed service provider being compromised. And since they would have access to things like the company devices at CTL, they could then use this access to devices to do other bad things. They could look at what is on the laptop. They could compromise the account of the employee and then use that account access to access all kinds of other systems, including the DLP itself. Lastly, we're going to add in a risk around privacy compliance because this is definitely more important these days. It's become more of an issue in recent years where a lot of companies in countries all over the world are not necessarily aware of their privacy obligations. And ignorance is no defense. If something happens, you could face big fines and other penalties. We've definitely found that a lot of companies that I've done audits and assessments on are simply not aware of the privacy requirements in their own country, let alone other countries where they may operate. They may have employees or customers in those countries and they're simply not aware. And again, ignorance is not an excuse. Okay, so I've come up with this summary table here of the different risks that we've come up with. I didn't want to be too excessive, but also wanted to give a good broad spread of different types of risks that you might encounter. If we think about things like the CIA, that typically is around access, confidentiality, even though it does overlap other ones. If we think about confidentiality, it's all about access control. So if you have any confidential information, you're going to need to consider access. If we then look at things like integrity of information, we can think of things like backups because we don't want things to be lost. If we think about availability, we have all of these different types of systems and how they may not be available. If we then think about physical versus cyber versus information security, in terms of cybersecurity, protecting things like devices, we've got the devices here, we've got the infrastructure that hosts the DLP. If we think about information security, we've already looked at things like protecting the data itself. And here we started off thinking about confidential information, even though it does go into other areas as well. We didn't specifically look at physical security so much, but it is rolled into this in a way because we have a lot of remote employees. And so when we're talking about protecting employee devices, that includes physical access to them. We then looked at the data flow diagram and we looked at how we have all these different systems that are all connecting to the DLP and how we can have different types of problems if issues were to happen there. And then we also just took a step back and thought, okay, it's a company, they need to receive invoices from suppliers and pay them. So that's a very normal risk that could happen to any company. It doesn't have to be related to technology at all. Because they use suppliers, you may end up giving a shipment away if someone poses as a supplier and they're not vetted. Because we have an IT managed service provider, this does have extra risk behind it because unlike these other suppliers, if they are compromised, it interrupts our ability to use their services. But if these guys are compromised, they can access the CTL systems themselves. So it's a lot more risky. And then just a general risk around privacy not being adequately looked at, because that's a very real thing that I see all the time. Inadequate incident response processes is also a very common risk that I see all the time, and you can find it all over the place. So I hope this gives you a spread of different types of risks that you can try to look for in your own scenario. Okay, so we finished identifying risks based on the information given to us so far by our client. In real life, it will rarely be this simple. You'll almost always find you have gaps, information is missing. So in the next video, we're going to look at what you can do about that. Let me know in the comments if you can think of any additional risks that we should have included for cargo trailer logistics.